Hey everyone, welcome. So today we're going to tear down and rebuild something we all use constantly, a real-time chat system. Like WhatsApp or Messenger. We're going to get right into the nuts and bolts of how these things actually work. Let's get started. Have you ever really thought about it? You hit send on a message and poof, it's on your friend's phone halfway across the world, instantly, even when your connection is, well, less than perfect. How does that even happen? How do billions of these messages just fly around the planet without getting lost? Well, that's the big puzzle we're going to solve today. Okay, so before we can even start drawing boxes and arrows, we need to know what we're building, right? So here's our checklist, the core requirements. We've got to have one-on-one chats and group chats. We need to see who's online and who's not in real time. And it has to sync perfectly between your phone and your laptop. But here's the really tough part. Every message has to show up in the right order, it needs to be saved pretty much forever, and it has to get there super, super fast. Yeah, it's a lot, but hey, that's what makes it fun. All right, first things first. Before a single message can be sent, we need to open a line of communication. So let's talk about the connection. How does your phone actually talk to the server and, more importantly, keep that conversation going? So this is a huge decision right here. You see, back in the day, we used something called HTTP long polling. It was kind of like a kid in a car asking, anything new, anything new, anything new, over and over. Your phone would ping the server, and the server would just wait and wait until it finally had something to say. The big problem with this is that it's just wasteful. So much overhead, so many empty requests, it's just not scalable for what we need. That's why today the clear winner is WebSockets. So what's a WebSocket? Think of it like a private, dedicated telephone line between your app and the server. It opens once and it just stays open. It's a two-way street. Your app can talk to the server and, this is the magic part, the server can talk back to your app whenever it wants. It can just push an update, a new message, right down that open line. No more asking. This is what gives us that truly instant real-time feel. Okay, our dedicated hotline is open. The connection is live. Now for the really cool part. We're going to follow one little message on its epic journey, all the way from sender to receiver. Let's trace the path. So here's how it goes. Step 1, you hit send. Your message zips up through that WebSocket to a chat server. Right away, the server does a couple of things. It stamps the message with a unique ID, super important for keeping things in order later, and then it immediately passes it off to something called a message queue. We'll get to why that's so important in a sec. At the same time, it saves the message in a database. Then the system acts like a switchboard operator. It finds out which server your friend is connected to and pushes the message down their WebSocket to all of their devices. Simple, right? Okay, I mentioned the message queue. This thing is the secret sauce. It's the unsung hero of the whole system. Think of it like a giant, super organized inbox between different parts of our system. The part that receives your message just drops it into this inbox and can immediately go handle the next million messages. It doesn't have to wait for the message to actually be delivered. This means if the delivery part is slow or even temporarily down for maintenance, nothing gets lost. The messages just wait patiently in the queue. This idea of decoupling services is absolutely fundamental to building systems that don't just fall over when things get busy. So what about those little check marks? Single check, double check, blue checks? This is how it's done. It's a series of acknowledgements, or ACKs. First, when your server gets the message, it tells your phone, got it, that's your sent receipt. Then, when the message lands on your friend's phone, their phone tells the server, I have it, that's your delivered receipt. And finally, when your friend actually opens the app and sees the message, their phone sends one last signal. It's been read. Each step is a tiny message flying back and forth to keep you in the loop. Okay, that flow works perfectly if everyone is online and has a great connection. But we all know the real world is way messier than that. So let's tackle the tricky stuff. What happens when someone is offline? And how do you handle a giant group chat? Right? So what if your friend's phone is off or the app is closed? Well, the server tries to use that WebSocket hotline and no one answers. So it switches to plan B. It sends a tiny little request to a push notification service. The ones run by Apple and Google. That service is what gives the phone a little poke and says, hey, you've got a new message. It's what makes that notification pop up on your lock screen. Then, the second you open the app, it reestablishes that WebSocket connection and says, okay, I'm here. What did I miss? And downloads all the new messages. Now, group chats. You can't just send the same message 100 times. That would be a nightmare. So we do something smart called fan out. You, the sender, send the message just once to the server. The server then acts like a mail carrier. It gets the list of everyone in the group, makes a copy of your message for each person, and puts that copy in their own personal message queue. It's a way more efficient way to distribute the message, and because it uses those queues we talked about, it works perfectly for everyone, whether they're online or offline at that moment. And what about that little green dot that tells you someone is online? That's not magic, it's a dedicated service we call a presence server. It works on a simple model: publish, subscribe. Think of it like subscribing to a newsletter. Your app tells the presence server, hey, let me know when Sarah comes online. You've just subscribed to her status. The moment Sarah opens the app, the server publishes an update, Sarah's here, and sends it to everyone who's subscribed. It's way, way better than your phone having to constantly ask, is she online yet? Is she online yet? Okay, we've gone through all the different pieces of the puzzle. We have our connections, our message queues, our presence servers. Now, let's step back and look at the whole thing, the complete architectural blueprint. And there you have it. You've got your gateways, which are like the front door bouncers. They don't need to remember who you are. They just manage traffic, which makes them easy to scale up. Then you've got the WebSocket servers, our dedicated hotlines for the actual conversation. Behind them, the message queue is our safety net, making sure nothing gets lost. The NoSQL database is our massive, infinitely scalable filing cabinet for every message ever sent. And finally, the presence servers are the lookouts, telling everyone who's online. Every single part has a job, and they all work together. So look, if you're ever in a system design interview and you get asked to build a chat app, this is your cheat sheet. These are the key talking points. Number 1, real-time means WebSockets, not polling. 2, your application servers should be stateless. It's the only way to scale. 3, you need a message queue for reliability. 4, use a NoSQL database for storing all those messages. 5, you absolutely need a push notification service for offline users. And 6, use a pub submodel for presence. If you can explain these 6 things, you're golden. So we did it. We've built a system that's incredibly fast, super reliable, and can handle a massive number of users. But there's one huge question left. We're storing every single message forever on our servers. So how do we protect people's privacy? How do we build a system with end-to-end encryption so that even we, the people running the service, can't read what's being said? Now that is a whole other level of complexity, and maybe something for next time.